Waves cannot just be described using the wavelength, frequency, speed, and amplitude. There are different types of waves. Most waves fall into two general classes: transverse waves and longitudinal waves. This really describes the relationship between the motion of the particles that carry the wave and the motion of the wave itself. In transverse waves, the medium, i.e. the particles, etc., through which the wave is moving, move perpendicular to the propagation of the wave. So if we visualize this as a disturbance passed down a rope, for instance, we can see the wave move to the right, but the particles, so if you imagine little black dots drawn on the rope, the individual particles are moving perpendicular to the direction of the wave. The second wave type is longitudinal waves. Here, the medium, or particle, move in the same direction as the waves. We can imagine this as a compression wave. So if we draw this and we have a region that's more highly compressed in the center, we can see that the wave is traveling to the right, and the particles, we have a higher concentration of particles where the wave front is, and they're moving in the same direction as the wave. Some examples of transverse and longitudinal waves. Any wave in the electromagnetic spectrum is considered to be a transverse wave. Electromagnetic waves are very diverse, but they include visible light, UV light, and microwaves, etc. Remember, electromagnetic waves require no material medium and can travel through a vacuum. This is handy because light can travel through space, so the light from the sun can reach us here on Earth. Another example of a transverse wave is a string instrument, so the waves that are produced on the strings, or water waves. These are mainly transverse in nature, but are quite a complex mixture and have some longitudinal component as well. Longitudinal waves, or the compression waves, some examples include pressure waves, or shock waves, and sound waves. So these are quite important when it comes to the physics of hearing. Just a note, I always remember transverse as it has an S in the word, and the wave looks a lot like an S. This helps me remember which one is transverse and which one is longitudinal.